What's going on, guys? It's the Unhinged Engineer back with episode 4 of my grad school vlog. So if this is your first episode, welcome. I'm getting my master's degree in computer science from Georgia Tech at night while I still work my full-time job during the day. And yeah, I'm 3 weeks into my first class, which is AI techniques for robotics. So if you watched the last episode where we dove deep into like all the technical stuff that I'm going to learn and the things going to be expected to do by the end of the course, you'd know that the first project is on Kalman filters, which is great because Kalman filters are something like I was loosely familiar with in my undergrad degree in aerospace engineering, but I never really like dove deep into and certainly never implemented myself. So when I found out that the first project was on Kalman filters, I was super excited. And it didn't disappoint. I enjoyed the project. I feel like I learned a lot. My understanding of them is much better, and I did implement one. That's what you're tasked with doing for the project. So yeah, in this video, I'm going to talk about what the project was in broad strokes, and then also what the experience of doing it was like. And at this point, I have tentatively completed the project. So there's like a series of test cases that I'll explain in a moment. But on those test cases run locally, I get a 93%, which is pretty nice. So yeah, I'm just going to like add some comments, clean up my code a little bit, just general good practice. And then once I'm happy with that, I'm going to submit it to Gradescope and should get a roughly equal grade because the test cases are the same, plus some additional ones that they sometimes add. But yeah, so I've tentatively completed the project at this point. I think it's at least safe to say that I'm not going to fail it, which is good. But yeah, so let's talk about it. So the project has two main parts. The first one is weighted much more heavily than the second. It's 70-30 split. So the 70% part is about estimation, and that's the part that requires the Kalman filter, right? So basically, there's this like asteroid field, and all the asteroids are moving through this field following projectile motion, right? And what you're trying to do is use a Kalman filter to estimate the positions of these asteroids one time step into the future with only noisy measurements of their current position to work with, right? And if you work with Kalman filters, you know that one of the main reasons we use it is because you can infer hidden qualities like velocity or acceleration just from measured quantities like position, assuming you can figure out the relationship between them, right? And so, or the relationship between them, which in this case is just basic physics, right? And so you set up a bunch of matrices for a Kalman filter, and you run that in a loop over and over again, and the parameters in those matrices get better and better over time, such that your estimation converges towards the true position, hopefully, right? And so, yeah, if you estimate the position of a certain amount of these asteroids with a certain degree of accuracy within a certain amount of time, you pass, right? And I was actually lucky enough to pass all the test cases for this section without like any tuning, right? So I initialized my matrices in a way that made sense to me based on the lectures and some of the other stuff they provided, like tutorial code, and it worked, which was awesome. So I didn't have to do a bunch of like tuning and tweaking, which unfortunately I did hear from like other students that doing that tuning and seeing how the behavior changes is very educational, but I'm not going to look a gift horse in the mouth. At the end of the day, it worked, which was great. Yeah, and then the second part was a little strange to me, but it was fine. It was actually kind of fun and didn't take very long. Basically, what you have to do is now you have a spaceship in that asteroid field, and you're trying to like bunny hop from one asteroid to another such that you get from point A to B, right? So yeah, you're kind of like piggybacking off that projectile motion in an intelligent way such that you get where you're trying to go. And yeah, in case you can't tell, like that was not really related to the Kalman filter at all. I mean, I didn't even use like the products of the Kalman filter from the previous section in this section at all, because I just kind of worked straight with the noisy measurements that was the input to my Kalman filter. Either way, like it was a little different, and I can't even like talk about my approach really because it's kind of just unique to me. Like I kind of just came up with something I thought worked, tweaked it a little bit more significantly than I had to tweak the Kalman filters, and it worked. So yeah, it was just kind of like a general coding assignment, I guess. And that was fine. So I currently have a solution that works for 23 of the 30% worth of the grade, right? So total 93. I'll take it. So I'm going to clean up the code a little bit and submit it over the next couple days, and hopefully I get an equal grade, which I should, based on what I've heard from other students. So, yeah, that's the project itself. And moving on to kind of the experience of doing the project, I think there's two main lessons I learned. The first one is that the progress was super duper nonlinear, and if you've worked on really hard engineering problems, you probably know that already. I think the difference for me here was that in undergrad, like, it didn't really get that hard until the very end, like senior year, technical niche classes, with like big projects. Versus this one, it's kind of like that from the jump. Like, this is the first project. It's not weighted any more difficult, any more highly than any other project. And so, yeah, like, you kind of just have to dive headfirst in the deep end, which is, I expected. I'm in grad school now, and things are different. And you're expected to be a lot more independent and autonomous and do a lot more searching for information and problem solving on your own, which is what I had to do, right? So that was good. It was a little stressful because there was like 2 or 3 days that I made like no progress. Like, I would sit down for 2+ hours and just like stare at my monitor until my eyes bled, right? Like, and I didn't make any progress. I barely wrote any code, and I was just like frustrated. And there was a certain point where I was like, okay, I'm not making any progress this way. I have to take a step back and regroup. And that was what I did. Like, I went back, I rewatched all the lectures, I retook notes, I reread the homework and resolved everything. I used to really like hammer home some of the concepts and pick up some of the things I missed. And then once I did that, I breezed through the rest of it, right? So very light, like a dip and then like a shoot in productivity, which was great, and I got it done. So I just, next time I sit there and I'm not making any progress on a project and I kind of just have to grin and bear it, I'll remember this and be like, okay, you're going to be fine. Just keep plugging along and you'll make it. That's number one. And then number two, I kind of alluded to in my previous episode, but like in this program, the difference in pacing between different students is like very, very drastic. And what I mean by that is, like, the day I started the project, other students were starting the next project. Like, they completed this one in its entirety and were moving on, leaving it in the dust. And, I have been working on this project for about, I want to say a week and a half. And sometimes I go on, like, the Discord or edX, and like people are starting the project now, right? So there's a much wider spread in terms of pacing than I'm used to from undergrad. Because like in undergrad, everything's done synchronously, and you kind of chug along as a class. You've got a test this date, and then homework due this date, and then a test after that, and then a final at the end. Like, everything's very regimented and very linear. And so it's a little like scary to get on Discord and like look at what other people are doing, because, all right, like, here we go, I'm going to dive in the project, and you see that other people are just done, right? But everybody moves at different paces. Some people are more familiar with this material than I am. I know, like, as an example, I'm much more familiar with the math than I am with the actual algorithm itself. There are some students who aren't familiar with the math, and they got to learn like some basic linear algebra stuff, which is okay. There's some people who aren't familiar with the statistics, or are familiar with all the math and struggle with the coding like I do, right? Either way, it's like everybody's at different places, and there's just a lot more fluctuation in this program than I'm used to. But that's also a great thing, because it's made to be flexible. It's made to work for non-traditional students who are working or doing other things. And so people from different backgrounds come and study, which is great. But yeah, it's just something to like know going in, that you're going to see people going at dramatically different paces and be like, what am I doing? But as long as you check yourself and the pace at which you're working and the things you have going on in your life, and you're working at a pace that's going to get everything done on time, then you have nothing to worry about. You're doing what you got to do. So just do it. Yeah, those are the main lessons. I guess technically speaking, the lectures were good. I think there were certain points where they could have gone in a little more depth, but like I said earlier, like, this is grad school, and you're expected to, do some more information hunting and example hunting on your own, and it set me up to do that well. Like, it illustrated all of the concepts well. It talked about like the statistics you need to know and the linear algebra you need to know, and some of the core points of the Kalman filter, like what I was talking about earlier, with hidden observations inferred from measured observations. Or hidden quantities observed from measured quantities. You get the point. Like, those core concepts, it drove home, so that when I was then looking at other materials, I could tie everything back together. And once I made that reset and reapproach, it went really smoothly, which was great. So yeah, I think the lectures were good. The problem sets were a little easy. I think they could have been a little bit harder and gotten you a little bit closer to what would be expected of the projects, right? Because the problem sets were like so much easier. I would say like each problem set probably took a day, and there were two, and then this took me like a week and a half, right? So it's pretty dramatic difference. But yeah, I mean, overall, I'm happy with it, and I think assuming that this is a performance of the lectures and the build up to these projects for the next few, I'll be completely happy with that. And I feel like I learned a lot from the Kalman filter here, which was the goal. So mission accomplished. But yeah, I mean, that's pretty much it for the Kalman filter project. Next episode, I'll probably talk about whatever I'm learning next, which I believe is particle filters, but there might be some stuff in between this and that I got to do first. Either way, I'll just keep talking about what I'm doing. I guess also there's those like optional challenges. There's like research challenges and hardware challenges that I was looking to tackle while I have a good buffer now that the project's done. So I might talk about those next week. But yeah, I'm just going to kind of keep plugging along and keep sharing it with you all. So thanks so much for watching. I'm the Unhinged Engineer. I make content about software engineering, AI, ML, like autonomous systems and drones. And basically, if you want to work on like super cutting edge technology and lead an awesome, badass career, this is the channel for you because that's my goal. And yeah, I'm just sharing my journey both in school and in work and life towards that goal. And if that's something you're interested in, please like, comment, and subscribe. Thank you so much for watching, and I will see you next time.